Good day, everyone. Welcome to our session. Today, we are going to discuss a related topic to what we had discussed last time about the trigonometric substitutions. So, today, we are going to discuss this integration of inverse trigonometric functions. So, we have here some reference. So, these are the formulas that we need to explore. So, these are the formulas for the integration of inverse trigonometric functions. Okay, so we have here, just to recall what we had in our differential calculus. So we have the derivative of inverse sine u or arc sine u with respect to x is equal to u prime divided by the square root of 1 minus u squared. Alright, and the derivative of arc cosine u or inverse cosine u with respect to x is equal to negative u prime divided by the square root of 1 minus u squared. And for the integral, so the integral of du divided by the square root of a squared minus u squared, this is equal to arc sine or inverse sine u over a plus c. Okay? Now, also from our differential calculus, if you take the derivative of arc tangent u with respect to x or inverse tangent u with respect to x, this is equal to u prime divided by 1 plus u squared. And derivative of its cofunction, which is the inverse cotangent u with respect to x or arc cotangent u with respect to x equal to the negative of u prime divided by 1 plus u squared. And for the integral of du divided by a squared plus u squared equal to 1 over a times arc tangent u over a or 1 over a times inverse tangent u over a plus c. And similarly for our secant, so the derivative of arc secant u or inverse secant u with respect to x is equal to u prime divided by the absolute value of u times the square root of u squared minus 1. And the other one is the derivative of arc cosecant u with respect to x or inverse cosecant u with respect to x equal to negative u prime divided by the absolute value of u times the square root of u squared minus 1. Okay? And for the integral, we have integral of du divided by u times the square root of u squared minus a squared. This is equal to 1 over a times arc cosecant absolute value of u divided by a or 1 over a times inverse cosecant absolute value of u divided by a plus c. Okay? So this information class is taken from this source. No? You can access or the details of these formulas from this link. Okay, so courtesy from this link. All right, so in our next video or immediately from this with this video, I will give you one example to apply this one of these formulas. Okay? So from those information that we have received just a while ago, so we have here a very good example. If if you are given the integral, the integral of, okay, so this is our example number 1. So if you're given the integral of 20 divided by 1 plus 16x squared dx. Okay, so how will you solve this? So as shown in a while ago, so we have here I'll just summarize the formulas class that we have just seen. So we have the integral. Now we have the integral of du divided by the square root of a squared minus u squared this is equal to arc sine u over a plus c. Okay, take note that you can also rewrite this as something like this: inverse sine of u over a plus c. So they're just the same class. Then the other formula is we have the integral of du divided by a squared plus u squared. This is equal to 1 over a times the arc tangent of u over a, then plus c. Okay, or you can write this as 1 over a inverse tangent u over a plus c. So they're just the same. And the third one, we have the integral of du divided by u times the square root of u squared minus a squared equal to 1 over a times the arc secant absolute value of u divided by a, then plus c. Okay, or you can write this as 1 over a inverse secant of the absolute value of u over a plus c. Okay, so from this summary of this formula, as you have noticed, class, no, from the first few minutes of our discussion, so we have the cofunction which they differ only on the sign. Okay, so to solve this problem, we have to first identify what is our a squared. So from the given, our a squared is equal to 1. Therefore, our a is equal to 1. Now take square root on both sides, you get a equal to 1. Then our u squared, okay, so our u squared is equal to 16x squared, or this can be written as 4x squared. So that is our u squared. So therefore our u here is equal to 4x. Okay? Then if you look at the, or if you take the derivative of this u, so what is our du? So our du from this, we have, if you take, we know that when you take the derivative on both sides, so we have du over dx equal to 4, right? Then you just solve for du by cross multiplying dx, or multiply dx both sides, so we'll get du. So we'll just do it immediately. So we have our du is equal to 4 dx. All right? But if you look at the given, so we have here 20 dx, right? So our numerator here is 20 dx, which is our we can compare it with our du. So we have to replace this by 20. So how to make this 20 since we have only 4? So to get the same as in the given, so we have to multiply both sides of this by 5, so that we have the exact du, or it will match with our given 20 dx. So multiplying both sides by 5, so we have 5 du, so equal to, so 5 times 4 dx, so we have 20 dx, which is equal to 5 du. Okay, so they are now matched with this. Then rewriting, so this is equal to we have our 20 dx in terms of du, so that is 5 du. So 20 dx, so we can have here 20 dx, so we have to replace that with 5 du. So we have the integral of 5 du, okay, divided by we have, okay, we'll just rewrite this formula, because this is in the form, this form class, this one. So we have to make use of this formula. So the formula is we have this is a, right? This is a squared plus u squared, okay? Because we can rewrite this as 5 times the integral of du divided by a squared plus u squared. Okay? Now substituting. So this is now in the form of du over a squared plus u squared. So the integral of du over a squared plus u squared. So this is 1 over a arctangent u over a plus c. So we have to make use of that formula. So we have 5, okay, times using this formula. So we have 1 over a times the arc tangent of u over a, then plus c. So substituting, we have 5 times our a is equal to 1. Yes, our a here is equal to 1. So substituting, so we have 1 over 1 times arc tangent u over a. Our u is equal to, as you can see here, our u is equal to 4x. So arctangent of 4x divided by a is equal to 1. Okay, then plus c, or this is equal to, so 1 over 1 is 1, so we have 5 arctangent 4x over 1 is 4x, then plus c, or you can rewrite this as, okay, I will write it here as we have 5 arctangent of 4x, then plus c. Okay, so you have this answer, either this one or you can have this. Okay, so that's it. That's our first example. Okay, so I hope you were able to follow the process, and I hope that you have understood the solution. Thank you very much. I will show you another example in our next video. Okay, bye.